Click. All right. So, for those who want to know the fun with numbers and why I am a bit of a math file, what we see here is wonderfully provided by God's auditor. He hated doing this. Dude, how painful was it?
I've been doing it for the last 6-ish hours. No, wait, 10 o'clock this morning.
God
So, and
damn.
it's 7 o'clock now.
Well, nice. So, okay. When I went through ATA school, so mind you, this is Navy military training. We had what was termed 2 class cleaners when you got to Strand. So you did your basic 8 weeks, where you did basic AC/DC theory, where you're not worried about anything. You're essentially treating everything as direct current. You're not worrying about phase angle or time period during the sine wave, none of that. It's just straight, this device is this resistance, takes up this much, and who the fuck am I hearing? Oh, there we go. All right. And back to the PDF. All right. When we got into Strand, we ended core with a civilian instructor. We started Strand with a civilian instructor because it was all math. And this is what we were doing in Strand, in iStrand. We called it vector algebra. It was circuit analysis for an AC circuit. Advanced circuit analysis. Oh, and I had fun. I actually started teaching other classmates in the barracks afterwards because this is the type of stuff we would go through. So right here. For load volts RMS of 110 at 85 degrees. That means at the 85 degree point of the sine wave of a VRMS, not peak to peak, RMS of 110. And a current RMS of 0.4 amps at 15 degrees. And then it has complex apparent powers of each of those points, real and reactive powers, which, that's where you really get fun in from electrical engineering into practical use, where this actually mainly comes into play is if you're doing circuit board design or energy management work. Then, lead and lag and load impedance. And this is just one question out of 7 pages of work. Thank you for showing me this. I wish I had a reason to do all this stuff right now, but we're doing simple frickin' logic design shit.
I'll fucking trade you. Oh my god, it took so goddamn long because it's not like when you're doing basic ass calculus where there's a set, there's a set of rules and stuff, but there's like a bunch of different avenues you can go down to figure out how to actually do it, and there's only one correct way to do it. It's just you have to remember so many different rules for when something is comprised a certain way and how to actually get to what they're specifically asking for. And my god, holy shit, I got a lot more respect for like you and Manya, because holy shit, this stuff is so painful.
I am so glad I never used to have to do lots of AC power stuff.
Yeah, DC is a lot simpler. But
oh yeah, I'm starting to hate Tesla now. I'm firmly on Edison's side. Edison had it right. Keep it all DC.
Yeah, but the numbers started to scare people because you can do the same amount of work with an AC current with less potential.
Yeah, I know. You know what? I also wanted to when I was taking Calc 1, I wanted to go back in time and fucking kill Newton just so we wouldn't have to deal with this.
Oh, Calc 1 is another... Actually, when I was doing my degree, the Calc professor for Calc 1 even said is, all right, how many of you in here are engineering types? And like all but 2 people raised their hand. He's like, oh, great. This is going to be a wonderful cleaner of who sticks with it and who doesn't. We started with 30. We finished the semester with 18. We had
Yeah.
we had that many people just drop out, not fail it, drop out.
Yeah, my first Calc 1 semester, I actually I dropped out because my first midterm was just terrible. I just did absolutely terrible on it. And well, okay, I'm gonna blame it almost entirely on my professor because she didn't teach. She'd just come in and do a song and dance and work out the equations on the board. Like I didn't know that there was a there was um how do I put this? I didn't know that the way you got derivatives was by using the difference quotient. Like she
Oh,
just taught difference quotient and then we moved on to derivatives. I didn't get a connection between the two. And so they ended up fucking failing out pretty much in the first midterm. But then I went back and had an actual good teacher the second time I tried, and I ended up getting 4.0s in Calc 1, 2, and 3.
yeah.
So
Yeah, I was going to say, it sounds like your second professor was like the one that I stuck with after that one because the teaching style made it
oh yeah.
entertaining, made it engaging, but also taught it in such a way that it made sense. Like, that professor, his whole thing, older guy, wonderful guy. His favorite thing to do was everything's easier with trig, and he was right when it comes to the calculus side of things. If you look at it and attack it from a trig standpoint, oh my god, is it so much easier. But all right.
My second professor, was like, "Hey, yeah, area under a curve, this kind of stuff." And then she was able to do like, different visuals with it to describe exactly how it was working and holy shit, it's amazing what happens when you like actually teach.
Oh yeah.
So,
Uh,
yeah, that's my biggest fucking issue with the university system as it is right now. I've had very few actual teaching professors. They just
they're there.
do a song and dance. That's it.
They're performers, not professors.
Yeah, I might as well be taking online classes. It doesn't fucking matter.
Yeah.
So, but yeah, so this is the fun shit that I've been doing all day while the rest of fucking Twitter and YouTube are exploding.
Yeah, I spent most of my day actually working and trying to problem solve why uh, an energy system kept spiking its DC portion from about 670 volts up to damn near 1,000. Well, I know what I found is the problem.
What?
A dynamic resistor across the DC bus.
Okay, so all right, I'm still a little weak on this. Give me a little more info.
Okay, so this system is it's a motor control system. So it's actually the VFD drive, the variable frequency drive that runs
Okay.
the motor. It acts as similar to a dual conversion battery backup system. You're taking line AC in, converting it all to DC, then off that DC bus, firing your SCRs to give a controlled AC output at the voltage and frequency that you want. Now,
Yeah.
in a battery backup system, it's going to be a constant load at, for the US, 60 hertz. Be it 480, 208, 230, whatever the output is configured for, that's what you're going to pull and convert the DC bus to. In a VFD, what you're doing is you're actually doing a solid 60 hertz, but you're varying the frequency, you're varying the voltage to get your frequency at the motor. So say it's a 60 hertz motor at 500 volts,
Okay.
but you want it to, and the motor runs at 1800 RPM full load. You want to run the motor at 900 RPM, so you want to run it at 50% load.
Yeah.
you're going to give it half voltage, half frequency from the VFD.
Yeah, that makes sense.
And you do that by how your SCRs fire. Well, when you have a lot of inertia that the motor is controlling, when you go into a braking situation, so you're slowing down the load, you're decelerating to a stop, the mass wants to keep going. Inertia is a thing you have to compensate for. And,
yeah, okay.
And because of this dual conversion you're doing, you are, as the motor is trying to stop but still spinning, you're actually regenning back through the motor onto the DC bus. You need to bleed off that extra current.
Yeah.
And that's where the dynamic braking resistor comes in.
Okay. So now is this like a badass potentiometer or what? Because I don't know what that is.
Well, so it depends. This one actually is a solid resistor rating, but it's dynamic in that it reacts differently depending on the amount of current you throw at it. But it's
okay.
Because they're typically an open core. They're an air core wound resistor instead of a solid device. You can have some that are the potentiometer type, but they're more intricate, they're harder to maintain, so a lot of industrial applications have gone away from them because they're just too expensive to keep in the system and running.
Okay.
So what was happening is after a good decel, the drive would latch an alarm on a DC overvoltage. And in order to clear it, you had to completely shut down and restart the drive. First time it worked. It went into the overvoltage again and then just stayed there and immediately went back into that state on power up again. Disconnected the braking resistor, disconnected the motor leads, started up the drive. Worked fine. Started up the way it should. No apparent damage. And so, meg to the motor megged fine. So, there is no phase to ground short at the motor itself. Reconnect the motor, start up the drive, left the braking resistor off. Started up fine, ran fine. It's like, okay, now let's do this. Checked resistance across that DBR. It's like, okay, we're reading 51.8 ohms. All right, let's see what it's supposed to be. Found the model number on the resistor pack. Checked the settings from the logic of the drive. It is supposed to be 100 ohms at 500 watts is the rating of that device. Again, we were reading 51.
Okay. So it was, I
cooked.
don't know if shorted out is the right word for it, but
yeah, because it's because it's the air core, we lost one of the two elements and it just straight short. It wasn't doing its job. Because what the dynamic braking resistors do is that regen current that's being thrown back onto the DC bus, which will cause an overvoltage, the braking resistor takes that excess energy and bleeds it off as heat. Yes, it is inefficient as fuck when you look at it that way, but it saves your logic devices.
And so what else are you going to do?
Huh?
Well,
what else are you going to do with
I got to dip out. The wife just got home, and I only heard about half of what you said because my dog was barking.
All right, no worries. Catch you later, man.
Good talking to you guys.